Hello, class. So this is another video um, on the Unit 9 random variable, and this today, right? Today I'm gonna get rid of the video. Today we're gonna do. I'm gonna try to do expected value, right? Expected value right here. Okay. So if you're ready, we may begin. So it says here, x is a discrete random variable. By the way, discrete random variables are random variables that take on values that you can count, right? Things like numbers on a die, right? You have one, two, three, four, five, six. Those are numbers you can count. Like uh, gender, right? How many gender, how many boys, how many girls? Those are things you can count. Uh, the opposite of discrete, I wouldn't say opposite. The other type of random variable is continuous random variable, and continuous random variables are variables that take on values that you can't really count them. Things like height, you can't really count because there's so many different ways you can measure someone's height. It can be 10.1 inches, 10.2. Sorry, that's rather tall. Maybe 6 feet, 6.2 feet, 6.3 feet. So there's always so slight variation for continuous. So you cannot count them, but you can measure. So that's how I usually see the two. So discrete random variable are random variable that takes on values you can count. Continuous random variables take on values that you have to measure. So the table below defines a probability distribution for x. What is the expected value of x? So you see all these values, x is 10, 20, 30, 40, and each corresponding value of x is its probability. So P stands for probability of x equals to that value, you see? So now the formula, all right, I'm just going to write it out. The expected value, right? The expected value has this symbol, E, and since it's x here, I put an X, right? And it is also mean, right? It also mean, and it has this symbol mu x. They all mean the same thing. Expected value is the same as mean. Is this symbol? Is this symbol? And it has this formula: summation of xi times the corresponding probability. So if you were to take 10, and summation means add, right? So 10 times zero point 0.2, because zero point 0.2 is the corresponding. So you just multiply them, multiply them, multiply them, multiply them, multiply them, and then you add them, you add them, you add them. That's what this gives you. So plus 20 times zero point 0.3 plus 30 times 0.15 plus 40 times 0.35. So if you do the math, right, which I will try to do it right now, but I have to take away the pen mode. So, and I have those values anyway, is to take 10 times, right, zero point 0.2 and plus it to 20 times 0.3, put the bracket here, plus 30 times 0.15 plus 40. Oh, I'd rather put a bracket just in case. 40 times 0.35, 26.5, right? 26.5. 26.5. Great job. Okay, so that's how you actually do it by hand. Now, there is another way. Another way to do this is to put, let me clear this, is to put this, all this value into a list 1 and put all this probability distribution into a list 2. So what I mean by list 1, list 2. So here we go. So go to the calculator, press stat, and then see how it's on edit, number 1. Now, I have a full list right now. I have a list 1 and list 2, and it has values and it has data. So I need to clear it. So go up, highlight L1, press clear, press enter, it's gone. So I need those 2 lists empty. So highlight L2, list 2, clear, enter. So let's go back to L1. Remember I said that I need to put this X values into L1. So 10, enter, 10, 20, enter, 30, enter, 40, enter. Then I need to go to my list. 0.2, enter, right? The corresponding probability, 0.3, enter. 0.15, enter. 0.35, enter. And what you do next is actually pretty clever. You go to stat, and then you go 1 to the right. You go to calc. And then number 1, look at number 1 var stats. So you click enter, and then they ask you, okay, where is your X list? Where are your X values? Yes, it's in list 1. And then my frequency list, in this case, you put in the probability distribution list, which is L2, right? But then L2 is in blue color right here. So you could press second, 2, and then immediately it gives you L2. Ladies and gentlemen, check this out. The expected value right there, the mean, right, is 26.5. Okay, so let's practice next question. So here, X is a discrete random variable. The graph below defines a probability distribution for X. What is the expected value of X? So instead of giving you a table, they give you a graph. And the values have 0, 1, 2, and 3. It is discrete, 0, 1, 2, and 3. I can quickly, because here on my left-hand side, all right, on my y-axis, I have all the probability distribution, right? For this one, for when x equals to 0, it's 0.35. When x equals to 1, it's 0.35. When x equals to 2, it's 0.15. X equals to 3 is 0.15. So let me quickly put that into a list. Go to L, actually clear L1, L2 first, and then clear L1. So let me put in the X values. So 0, enter, 1, enter, 2, enter, 3, enter, and then let me put in the probability distribution. So here is 0.35, 0.35, then for the X equals to 2 and 3, it's 0.15, 0.15, 0.15. Now, it's also here that I want to say something. A valid distribution, right? Probability distribution will always add up to 1. So 0.35 plus 0.35 is 0.7. 0.7 plus 0.15 is 0.85. 0.85 plus 0.15 is 1. Okay, so go to stat, go to calc. Number 1 is what we want, or you can just press 1, and it's L1, L2, right? Like we previously put L1, L2 right here. The expected value is 1.1. So it just means expected value means in the long run, if this is something that you do consistently, right, you will expect the value to be 1.1. All right, the mean is going to be 1.1. Okay, I will try to do another one. So let's Omo Joby is entering a winner take all World Series of Poker tournament that cost $10,000 to enter. The prize for winning the tournament is $200,000. So Omojobi estimates that there is a 2% chance that he will win the tournament. Omojobi calculates his expected return of entering the tournament to be negative 6,000. So in the long run, he actually loses money, right? Yeah. So choose all answers that apply. So with a negative 6,000, what does it mean? So A, is it possible for it is possible for Omojobi to have a positive return from the tournament. Well, yeah, why not? Could it be possible? Right? Because he could, enter the tournament the first time and then win it. Low probability, but he could. Is it part B? Option B. It is possible for Omojobi's return to be exactly negative 6,000 from the poker tournament. Yeah, if he keeps playing, right, his return could be exactly negative 6,000. Who say it cannot be? And option C, it is possible for Omojobi to have a negative return for an investment. So sounds like all three doesn't work. Well, don't skip. I might have to get back to that list. Which one is it? Omojobi. It's not this one. Different questions. Right here. So Omojobi. It is possible to be exactly negative 6. Return to be exactly negative 6. It is possible. Yes. It's possible to have a positive return. So it looks like it's not a positive return, it's a negative return. All right. So I made a mistake on the last one, thinking that because I checked all three answers, um, and my thinking was this: is it possible for Omojobi to have a negative return from the tournament? Well, of course, if he plays, but if he doesn't win, then he loses the $10,000, right? But is it possible for him to have a positive return? Of course, if he wins, then he actually makes 190,000, right? Because he has to use the $10,000 to actually pay to enter the poker tournament. So, but then the third one, I checked that thinking that, is it possible for him to have exactly negative 6,000? And I clicked that thinking that it was possible, but it's actually not possible, right? Because that negative $6,000 here, it is just kind of what you would expect if he does it a long series of tournaments again and again and again and again. So we don't actually expect him to come back exactly negative negative $6,000 from the poker tournament. So anyway, that's how we do it. All right. Thank you. So if you have any questions, you let me know.